Welcome, everybody. This is the second of 4 webinars in our Action Now Accelerating Pathways to Decarbonization Summit. Thanks so much for joining us. We're going to give it another minute. There's over 300, almost 400 of you that registered for this. So thanks so much for being here. Please take a look at the webinar ground rules and viewing tips. Please note that the chat function, which is going to stay up throughout the webinars for general questions and comments. If you have any tech issues, you can note them here. We'll be including links to resources throughout the webinar. These are for general comments in the chat. The Q&A function is specifically for formalized questions for the panelists to consider. So these are very content-specific questions for panelists. The panelists will not be paying much attention to the chat. And finally, I wanted to encourage you to control your viewing experience by selecting either the grid or the speaker view. It's typically at the top of your screen. As a webinar attendee, you're in a view-only experience, so your audio and your video is already disabled. But you can control how you see the speakers on video. And a grid is nice for a panel discussion. We'll get started in just a minute. I also wanted to make a quick note about continuing education credits. So my colleague Zoe, her name is Zoe AIA Seattle in the chat. She's going to be available to answer questions, and she may reach out to you directly if she has any questions about your registration. But if you registered for this webinar, we're seeing your name on the back end. We'll be able to cross-reference that and get you continuing education credit. This webinar is worth 1.5 LUHSW. So this session is called Embodied Carbon, the New Frontier. It's going to be some short introductory presentations and then a panel discussion led by Simonen. We're also excited to welcome Landry Watson, Kjell Anderson, Keith Lindemulder, and Jordan Palmieri. I want to give a special thanks to our summit sponsors, our gold sponsors, Arup and Better Bricks, our silver sponsors, Alana Buick and Bears, DCI Engineers, FSI Engineers, McKinstry, Stantec, WSP, and thank you also to our bronze sponsors listed below. If you want to see the rest of the webinar schedule today and view a full program schedule with speaker bios, you can visit aiaseattle.org and the Action Now 2020 event. All webinars will be recorded, so those will be sent out tomorrow. If you miss any today, don't worry, you can still access it. We're not providing continuing education for any later viewings, but definitely those resources will be available for you. All right, so with that, I'm going to stop sharing my screen. I'm going to say hello really quickly. My name is Cassie Blair. I'm the Associate Director of AIA Seattle. And I'm very grateful for your participation today. We are all really inspired. We wish we could be together in person, of course, but we're really inspired by everyone's desire to stay connected and to continue learning and to participate in this conversation about climate action and specifically right now, embodied carbon, the new frontier. So with that, I'm going to hand the metaphorical mic over to Kate Simonen. Thanks, Kate.
Thank you. Hello, everybody. Really happy to be here. For some reason, my sound seems a little crackly, so hopefully it'll come in okay. So I'm here to talk to you about embodied carbon, which we're calling the new frontier. And I'm going to start here by giving you an overview of what embodied carbon is and what embodied carbon actions are possible. And then I'm going to invite in our 4 panelists to talk with you and give their ideas about what architects and design professionals can do now and over the next few years to really make a difference on these embodied carbon impacts. So I direct the Carbon Leadership Forum, and this group hosted at the University of Washington envisions a transformed, decarbonized building industry. So we're looking to enable better buildings for a better planet, and we focus on the emissions from building material manufacturing, or embodied carbon. We conduct research and create resources and convene a network, all aimed towards advancing this mission. We're asked to give a little bit about ourselves. This is a little graphic that is showing me today in the sort of teeter-totter of life from when I started practice in the 1990s to where I hope to be, that we'll be in 2050, coming together and creating a world that's healthy and thriving and a climate that's sound. So how do we get to that future? The work that I'm doing is recognizing that that's all through collective action, and in order for us to tip the scale, it's not an individual, it's all of us together moving towards that future. When we look at global greenhouse gas emission targets, this on the left is from Architecture 2030. In order to meet those global greenhouse gas emissions goals, we're needing to get to zero carbon. What was 2050, it's moving forward to 2040 because we hadn't been making enough action in the past 10 years. And so then this next 10 years is really a critical decade that we really need to get on the order of 50% reductions in greenhouse gas emissions so that we have the opportunity to get to the future that we want. And so there's an urgency of action that's also coupled with the magnitude of impact of the building sector. So this pie chart on the right is showing the operating buildings, so heating, lighting, and cooling. But if we look at the impacts from building material manufacturing, there's an 11% part of the pie. That's from major industries like steel, cement, glass, and aluminum. But there's all sorts of other manufacturing and transportation that's related to building materials that we can estimate that the total impact of buildings can be as much as half of the total greenhouse gas emissions. And that's, if you just sort of look around our world, what we see by volume and mass are buildings. So it is that infrastructure that drives a massive amount of the global greenhouse gas emissions. And when we look at emissions tracking, here I have an example of the California greenhouse gas emissions. California is really at an exciting trajectory in that fact that their GDP is increasing and their population is increasing, but the total value of greenhouse gas emissions is going down. So per person and per GDP are all going down. But if California, as an example of where we want to go, is down to zero by 2040, we have to recognize that the emissions that we are responsible for are not just the emissions that we emit in a single location, but it's also for the emissions related to the goods that we purchase and bring into our region. And so this is sometimes called the carbon loophole, in that if we track only the emissions that happen in our own facility, like our own house or our own state, we're missing the emissions that took place from material and product manufacturing. So in the building sector, we call those emissions embodied carbon or embodied emissions. And those are the emissions that take place when factories run, you drive trucks, you install and maintain buildings and eventually dispose of the materials in buildings. And that's compared to operating carbon, the carbon from building light, heating, cooling, and all of those things. And we're calling embodied carbon the new frontier because we have been spending a lot of energy focusing on the operating carbon and not as much on embodied carbon. And when we look at why that has been the case historically, the building on the left is sort of the typical understanding of a total carbon emissions of a building. So the operating carbons of a typical building built in 1980 over an 80 to 100-year lifespan, the operating impacts are a large chunk and the embodied impacts are less. But as we increase our energy efficiency and decarbonize the electrical grid, we get to more higher performing buildings where the relative contribution of operations goes down and the relative proportion of embodied is up. Until you get to a case like the Bullitt Center, which is operating energy zero, the operating impacts are none, and 100% of the impacts are from the materials in manufacturing and production. And not only are these impacts more relatively important as we've made success on reducing operating carbon, they take place up front, so before the building is occupied. So for the buildings that we built today, and we're looking at decarbonizing between, having radical reductions over the next 10 to 30 years, if you look at a building over that 10 to 30-year lifespan, more than half of the impacts for even just typical buildings are related to the materials that go into them. When we're looking to understand embodied carbon, we're using a methodology called Lifecycle Assessment or Environmental Lifecycle Assessment. So similar to life cycle costing that looks at the cost of a choice over the entire life cycle of a building, environmental life cycle assessment, instead of tracking dollars, tracks environmental impacts such as greenhouse gas emissions or carbon, but other ones such as smog formation or acidification. So this diagram on the right is demonstrating the different scopes of those emissions. They're from material extraction, so driving trucks to harvest trees or extract raw materials. It's transporting them to a factory. It's manufacturing at the factory, so it's the electricity that goes into the factory. It's the chemical reactions that take place at the factory. It's perhaps even burning natural gas or coal or biomass at the factory. And then at the end of life, what happens? Is it reused or recycled, or does it go to a landfill where things degrade over time and have more emissions? If we're looking at a building and wanting to understand its embodied carbon impacts, we're really looking at two things. We're looking at the quantities of materials that are used, so how many cubic yards of concrete, how many square feet of glass, and then the embodied carbon impact per those materials. So those are typically generated in data sets that give you emissions to produce a single unit of material, like a cubic yard of concrete or a kilogram of steel. And those can then be wrapped up into a whole building life cycle assessment or whole building embodied carbon assessment, where you can find the relative contributions between different component parts or compare between two different design options. So changing out your structural system or your facade system, you could compare them. There's three main strategies for reducing embodied carbon. The first one is using it smart, so that's reusing existing buildings, building something smaller, build smart, so this is where you're deciding which system to use and trying to compare alternate assemblies. And in that case, you really need to look at the total life cycle impact, because a straw bale wall and a glass curtain wall perform differently over their use and end of life. And then the third one is buy smart, so that would be purchasing the lower carbon option when you know that you're buying something. So let's say I'm buying steel, can I buy the lower carbon footprint steel that performs same or similarly? One method that's used to evaluate embodied carbon is an environmental product declaration, somewhat like a nutrition label. Instead of cups of servings, it provides a cubic yard or cubic meter of concrete, and instead of carbohydrates or fiber, it's giving you an environmental impact like climate change, embodied carbon. It should note that these are less like a nutrition label and more like a miles per gallon on the car, that they're directionally accurate. A car with a higher miles per gallon typically gets more miles per gallon than one with a lower, but we know that there's some variation that happens in the actual implementation of that. If we look at a total building impact, here's a high-rise building in which we looked at everything from structure to envelope and mechanical, electrical, plumbing systems. This orange bar is the MEP systems. That the that the relative contributions of structure and enclosure are very significant. But if we look at interiors and other systems, they too can be a major contributor. So there's multiple tools available that can help you evaluate embodied carbon. Specific one that the Carbon Leadership Forum helped to incubate is the Embodied Carbon and Construction Calculator. So that's a free online tool that you could use. And so, I'm answering my question, what are things that you could do today? We have three main sort of strategies, or actually maybe steps, levels of engagement. So if you're just entering the world of embodied carbon, we've got 3 articles that or 3 places that we'd recommend you go. And at the Carbon Leadership Forum website, it'll link to them. This one's really fun. It's less than a minute and a half long of introduction to the topic. So this is a great one to share with social networks, your family, colleagues who are really just to make sure they are aware of the issue. Then if you're wanting to implement this in practice, we have multiple resources at the Carbon Leadership Forum website to help engage. And one that I'm particularly excited about is a new online communication forum that is now open, and we've got over 1,000 people in different focus groups and regional hubs sharing information and acting. And then if you're looking to get more details, in addition to some more detailed resources like this roadmap for reducing environmental impacts, where it goes through, if you're in pre-design phase, what are some things that you can do? So that's resources at the Carbon Leadership Forum website. And then there are others like Architecture 2030 that I'm hoping will get shared in the chat. So we're able to do this work through the generous support of sponsors and volunteer contributions from our partners. So we're really excited about that. And so that was my big picture or introduction to embodied carbon. And now I'm going to hand it over to Kjell Anderson, who will
All right. Hey, thanks, Kate. My name is Kjell Anderson, the Director of Sustainable Design at Element Architects, and I get to represent architects on this panel. We choreograph much of the design process and are ultimately responsible for coordinating massive reductions in carbon over the next 10 years, 15 years. Make no mistake, this is an ethical challenge. Our industry is responsible for 40%, 50% perhaps of all global climate change emissions. We like to see ourselves as problem solvers, not the architects of the problem itself. But we are the problem in many cases, and we need to fight inertia every day in order to solve it, which is why you're here for Action Now. Here we are, that's me. All right, what drives me? Here are my 2 kids, Carmen and Lena. We all love the outdoors. Leave it better than you found it is a slogan that drives me. Am I gonna do my part to leave our children and grandchildren an earth I'm proud of? Are we going to be able to say we did everything to give them the same opportunities that we had? This includes equity and many other elements, but my focus is on the architect's role in fighting climate change. I was lucky enough to hear President Obama speak at Greenbuild last year, back when conventions were a thing. When asked about the biggest political problem, he responded that we say things about our values. We say we believe things, but where we spend our time and our money often doesn't align with our stated values, and this really struck me. Climate change. Are we spending our valuable lives doing the important work of architecture in alignment fully with our values? Are we spending our money on things that align with our values? Now, often the answer is no, but how do we get closer to an emphatic yes? So Action Now, what can we do? 2 things. First of all, we do many things as architects, many important things, from programming to envelope design to specifications and CA. So I'm going to make this as simple as I can. 2 things, engage in embodied carbon modeling and engage in energy modeling. This is about providing data to our team so we can make decisions. Does that mean we do the modeling? For some of us, yes. For most of us, though, it means seeking out the data so that we can help ourselves and our clients make responsible, informed decisions. Is a project you're working on right now advancing your firm in these 2 areas? These two are our biggest levers as architects in accelerating our projects towards carbon neutral design, which is what many of us have signed on to do by the year 2030. And the AIA is in the midst of transitioning so that carbon neutral design is standard practice. At the bottom of the diagram showing total carbon emissions from these two sources over 60 years on one of our projects. The blue shows a code compliant building. Seattle Energy Code, pretty advanced. The orange shows an electric-only building with mass timber, natural ventilation, and an advanced envelope that was informed at every stage of design by energy modeling. We are on track for roughly 60% total carbon reduction from a Seattle code building because the design team was informed by embodied carbon modeling and early energy modeling. So a crash course on how we do these, starting with embodied carbon. Embodied carbon modeling has been around for decades, but a modern era started in the last 5 years with widespread use of architect-usable tools, Tally and now EC3. Elements started with embodied carbon modeling by experimenting with using Tally on 10 wall assemblies to see the relative impact. It's great because it started with something we know and control, envelopes. We control almost entirely as architects. And when you start, you always need to start with something you know well, so you can calibrate your understanding of how the model's outputs to what you already know. To understand more about the impact of tenant improvements, we started with our own office. We gathered plans and some specifications going back to 1995, and we put together a spreadsheet of products, quantities, and carbon emissions from the environmental product declarations. This spreadsheet was based on a CLF calculator. Since there was a time gap, we assumed another renovation would likely happen before LMN moved in. Looking at the cumulative carbon emissions on the far right, you can see that TIs over 60 years have roughly the same embodied carbon as the structure. And when considering we could now take about a 30% reduction in concrete emissions with high replacement content, the cumulative values show the TIs in a modern building on the right are likely to be more impactful than the structure and envelope when considered over 60 years with a typical TI scenario that we do these days. Our office is actually 100% open office. There are no enclosed offices in here. So this is also probably underreporting what typically happens in enclosed offices and in workstations. So we have engaged in embodied carbon modeling, starting small, especially using as examples projects that we know a great deal about. And the secret sauce involves these three things under action now. 1, gathering data. Environmental product declarations can be required to be submitted within your specifications. What gets measured gets managed. If you can't get an EPD, it's tough to make informed decisions about any product. Learn to read an EPD in the typical categories A, B, C, and D. We typically focus on A for embodied carbon. Just download an EPD, any one you want, and get familiar with how it is written, and then you'll be much more informed on how to read others. Number 2, get familiar with the software or find someone who is. Tally and EC3 are simple enough to use with only online training videos. But you should also join the Carbon Leadership Forum email list in the CLF Seattle chapter, where we do presentations and discussions on these tools. Number 3, use 1 and 2 to make decisions, informed decisions. Lower carbon concrete is easy enough to specify if you work with your contractor and structural engineer. There are also many other products like steel, gypsum board, carpet, ceiling tile, where you can find preferable products to spec. Remodeling will tell you which are the most impactful for your project and what you should focus on. You also need to calculate the embodied carbon to be able to specify targets for concrete, for example, to include in your specs. Goals for that are often in Division 1 and the structural divisions, but EPDs can be requested in any division. The most important thing with embodied carbon is to get started, wherever you're starting from, as Kate said, and start with something you understand and control. And don't be afraid to reach out to others, as we're all learning together. Okay, so engage in energy modeling. I hope you've seen this, the 2030 challenge chart, leading to carbon neutral new buildings by 2030. You should also be reporting. The deadline was extended to April 23rd this year for AIA 2030 commitment, so please report. Here's what I overlay on the chart. As architects, we are responsible for passive design. If we do it right, we can eliminate or downsize mechanical systems. The challenge, of course, is that mechanical engineers who design the active systems typically have energy modeling in-house. We as architects don't have this service in-house, meaning we don't generally generate data telling us how we are doing with our passive design, but we still must engage in energy modeling. What does this mean? This means we work with our mechanical and energy analysts to understand how our envelopes are performing. While we don't do the modeling, we need to lead this process by asking the most impactful questions of our consultants. If we are able to downsize or eliminate mechanical systems, we can save money and embodied carbon because, as Kate showed, mechanical systems actually have a significant embodied carbon impact. And we can transfer the money from M and E to the envelope while reducing energy use. RMI calls this tunneling through the cost barrier. If we can actually eliminate a mechanical system by improving the envelope, which we've done on many projects, we can find large savings and transfer those to the envelope to get large energy savings. 3 more tips. These are my last tips. As most energy modeling will show that the envelope improvements don't actually save energy, but this is false. I repeat, we get misleading information often when we ask our energy analysts for information about the performance of the envelope for 2 reasons. 1, we are not asking for the right information, and 2, because thermal comfort often isn't being adequately considered in their results. So number 1, we need to ask for peak cooling and peak heating out of the energy model instead of just annual energy use. Peak cooling and heating are often driven by envelopes. With better envelope, we can reduce the size of the mechanical system, saving cost, or perhaps just transferring it. If we reduce the peak heating or cooling enough, we can in some cases use a more advanced mechanical system. And because we already reduced the size of the mechanical system, an advanced mechanical system now costs less. So ask for peaks. Number 2, comfort. Most energy modeling results don't consider thermal comfort adequately. Often people near large windows are too hot or too cold, so they ask for additional heating or cooling to be turned on, driving up energy use. Models are not good at predicting this unless we as architects specifically ask for it. Ask for mean radiant temperature in perimeter zones, and you will probably get the right answer. Of course, number 3, if we don't have early energy modeling services, and I mean SDN earlier, we fail. Get it in the contract. So a couple notes about carbon. Carbon and energy are related, but it's a very complex conversation that we don't have time for right now. In general, reducing energy use reduces carbon emissions, and to bring it full circle back to embodied carbon, the infrastructure that it takes to generate energy, if we reduce energy use, operational energy use, it actually takes less embodied carbon in the infrastructure of energy. So we're actually saving not only a lot of water, a lot of energy, but we're saving embodied carbon in the infrastructure of energy. So engage in embodied carbon modeling and engage in energy modeling. This gets us closer to understanding the total carbon picture of a project. I hope this slide makes more sense now. This kind of comparison between embodied and operational can help us as architects determine if more insulation, better glass, shading, or other changes is an overall climate win or not. With that, I am going to hand it off to Landry. Thank you.
Is everybody hearing me? Audio? Okay, good. All right. Hey, I am Landry Watson. I work for Alexandria Real Estate. I'm here to help hopefully represent the owner landlord side of this conversation today. Alexandria Real Estate is an urban office REIT. We tend to build almost exclusively for advanced tech and biopharma. So we build labs, which are huge energy consumers. We are a market cap of about 26 billion, and we have almost 30 million rentable square feet spread across 7 major markets where we cluster our buildings. Specifically on the West Coast, you've got Seattle, San Francisco, and San Diego. On the East Coast, you've got Boston, New York, Maryland, and the Research Triangle. Specifically, I'm the executive director for sustainability, and I support the West Coast, all of our new construction and national initiatives. Embodied carbon is definitely one of those. Prior to that, I spent about a decade with a general contractor, so I've been on both sides of the table in the OAC. So I have a little bit of perspective on kind of the finger pointing and the discussions of who's at fault with respect to either lowering EUI or potentially embodied carbon. And we'll talk about those a little bit later. The question to us posed by panelist Kate was what drives you? And what I'll say, I of course echo everything that Kate and Kjell said, but what I would specifically say as being on both sides of the OAC and understanding, you know, whose money is being spent, I am more passionate about reducing embodied carbon right now than I am actually in reducing operational carbon. Operational carbon is fraught with disaster. Even when you feel like you're the landlord or the owner of the building, you've always got a customer who would spend as much or consume as much energy and or resources or water as they feel necessary for their investors. And you've always got kind of a market rate delivery that's fighting against that. And so you're constantly battling your investor base, which you have to deliver yields in order for people to invest in your stock. And you've got to always have conservative buildings where people live and consume energy. And so those things are fighting against themselves, to be honest. Embodied carbon is a place where I feel like we can drive capitalistic and market rate changes. If we continue to demand lower carbon materials, starting with the structure and then eventually getting into the finishes and things like that, then we can change the way that the industry produces these things. Those are all capitalist decisions and the capitalist dilemma. If you believe that operational carbon or just the consumption of energy is driven by capitalist decisions, then just take a quick peek at what happened to fossil fuel over the last 3 days. And if you believe that something sells at negative $40 per barrel, then I can't convince you one way or another. But what I can tell you is that materials get made and they get delivered in a certain way, and we can affect those, and we can affect those right now. So what can we do right now? Without echoing absolutely everything that Kjell just said, we have to start right now. In fact, we're a little bit late to the discussion. We've been completely and totally focused on operational carbon for about the last 20 years, and yet we still struggle to communicate things like EUI, kBTU per square feet. How do you transfer kWh to that? What does that mean in metric tons of carbon? How much does that cost? What's that price tag per square foot? All of that vernacular we need to be talking right now. And if we're going to be talking about embodied carbon, then it's kilograms and it's pounds and it's tons, and then it's price tag per square foot, right? We've got to understand that. We've got to understand how much the price tag is in Washington versus the price tag in California versus the East Coast in New York City. So what can we start doing? What I can tell you right now is without even spending a penny or changing anything about your design or procurement, we can start by benchmarking our buildings during construction. He's absolutely right. The tools that are out there right now with some simple, kind of stick-to-itness and just a little bit of data entry and kind of, understanding where to find numbers. Anybody that can do data entry can work on the EC3 and also in Tally and Athena. You don't need a full LCA to start engaging this. And that's exactly how the EC3 was developed. We're going to talk about that later on in our commitment to it. But the bottom line is it was designed for non-technical participants to be able to take it, put numbers to it, push it against the EPDs, and then come out with a carbon number, and then have those conversations. So number one, we've got to start educating everybody in the delivery of design and construction about what that vernacular is. So we've got to learn that vernacular, right? We've got to start benchmarking our buildings. Even if you don't change your building or change the materials in your building, at least you understand what that miles per gallon that Kate was talking about earlier with respect to carbon use intensity or carbon intensity. We can at least begin to understand what that translates into carbon and what that price tag eventually becomes, okay? You put a price tag on it and you manage it like Kjell was talking about, then you can reduce it, okay? And then just, the last thing, I hate bringing up commitment organizations. Look, the industry is fraught and just littered with commitment organizations. And I'm not making, it's not bad. I get it. You're not fully in control of certain things, and it's the landlord's fault. It's my fault, right, for not buying a more efficient building or something to that effect. But you've got to commit yourself to it, just like he's talking about committing to early energy modeling and early carbon modeling. You've got to have it. You've got to get it out there, and you've got to get it into the budgets and the discussion before it becomes a VE item. If we all wait until the ribbon cutting and then say, but don't you want to be carbon neutral? You're not going to find any owner or any person that's like, sure, let's spend a bunch of money now and fix this, right? So learn the language, get committed, and let's get started right now. And that's what I would say for this portion of the conversation. And we'll happily answer some questions later on.
Great, thank you, Landry.
Jordan? Sorry.
No, that's Keith Lindemulder from Nucor Steel.
Keith, sorry.
It's not. Hi there, Keith Lindemulder here, and I can get to the top of my presentation. There it is. I work for a company called Nucor. Nucor is the largest and most diversified steel and steel products company in North America. We do have 25 scrap-based steel mills around the country, and with about 27 million tons of capacity, but in addition, also about 7.5 million tons of downstream product capacity. Most products, most of you would be familiar with. An important piece here is we are North America's largest recycler. By mass, recycle more weight in material than any other single company in the entire continent. Our market leadership, both structural steel, steel joist and deck, piling, metal buildings, merchant bar, cold finish bar, and conduit, rebar, steel and fabrication, hollow structural sections, plate steel, and special bar quality steel, number 2 in the marketplace, and sheet steel, number 3. I have been the environmental business development manager out of our corporate office for about 11 years now, been with the company for almost 16. It's been a great company to work for, and hopefully we can talk a little bit more here now of why. So one of the questions is what drives me, and one of those important things is to continue to do the right thing. The idea here is to continue to do the right thing in terms of how we manufacture products, but not only that, how we sell them and how we find a way to place them in the marketplace. My goal has always been to make a lasting difference, to not only do what I can personally, but associate myself with folks that can also make a difference in the marketplace. And I think we have a lot of those on this panel today. And then finding solutions to difficult problems, of which we can talk about today. My picture on the bottom there is my family, my 3 kids and my daughter-in-law, and well, some of the family pictures we've seen today are younger kids. Mine are adult stages now, but that doesn't matter. That's still the important factor that drives me today. So, as Kate mentioned about embodied carbon, we're seeing as a material supplier a continued focus on embodied carbon in the materials that we sell and produce. And in some respects, that makes us a target in terms of who the market starts focusing on in order to find the low-hanging fruit. So as we've heard several times, as operational energy efficiency improves and greenhouse gas emissions due to that energy efficiency decrease, it becomes more and more important to take a look at carbon in a variety of products. I work in the steel business, and not all steel products are created equal. I'm sure every single product in every product family could say exactly the same thing. And I hope today we can deal with a couple of those things that might help find more appropriate steel products for the projects that you guys design and build. So what can we do? What can architects do? You can understand some of the basic challenges in the marketplace. We've heard from Jordan and Kjell and Kate already about why this is important, but also understand a little bit about how the supply chain works, some of the challenges that your material suppliers may have in meeting this challenge. It's important to not just say we need a product with less carbon in it. That's obviously the goal. How we achieve that and how we get there becomes a challenge. Get us involved early, and by us I mean all material suppliers. It doesn't really help at all if when we find out that this is a project that has a embodied carbon concern or target or is even a lead project, for example. It doesn't help the project at all if the material supplier comes in at the end of the project just to document what has been sent. There's no opportunity there for improvement if we're just documenting what's already happened. So I encourage everyone to get us involved early, ask questions, even if they seem like basic questions. The supply chain is relatively long for a lot of these products. That goes through a lot of steps, and I can assure you that there are varying degrees of capacity and knowledge across that entire supply chain. So ask the questions and make sure you get the answers. As we've heard a couple times already, continue to use environmental product declarations and other tools like EC3 to screen for your products. But past that, once you've identified that product, make sure that once you've identified not only the product you want to use and the assembly you want to use, but when you decide which supplier should supply that product, make sure you understand how your purchasing process works, and that the product that you actually want to have identified is actually delivered to the project site. All too much and all too often, a lot of these products are relatively anonymous, and selling products into what can be considered a commodity market becomes a bit difficult to trace and track as we move forward. So again, goes back to asking questions, getting people involved. If we know we need to supply something, that's generally what we can do. And at a minimum, and I say this in all seriousness, at least in the steel business, at a minimum, use American sourced steel, or at least North American sourced steel. And the reason is not as much for transportation, although that's a component of it. The steel industry in North America has transformed over the course of the last 30, 40 years to significantly electrify the steelmaking capacity in this country. Almost 70% of the steel produced in North America today is produced via the electric arc furnace, as opposed to the integrated or basic oxygen furnace process. There is a difference by approximately 1.5 to 2 times less carbon emissions via the EAF process than you would see in the integrated steel process. As a note, all North American produced long products, which would be structural steel and rebar primarily, all of those products are produced in North America via EAF. So again, if you specified North American produced steel for rebar or structural steel, there is an extremely high likelihood that you're going to receive steel that was produced in about as efficient way as possible. So what else is happening in the world today? We again have been a bit of a target for some of this. A lot of the Buy Clean legislation, specifically in California, which is the only state right now with a law currently on the books. Of the 4 products listed in the Buy Clean California law, 2 of them are steel products. One is structural steel and one is rebar. Flat glass and hardboard mineral wool insulation is the other. So our goal has been to stop being the target and start being what I would consider to be the tip of the spear, to try to bring solutions to some of these difficult things. In California, a little history there, it is a current law, and through this history, you'll see some of the challenges that we face as a material supplier in this process. So it is a current law. The law applies to state-funded projects. That's an important distinction, and they are currently in the threshold setting process. The idea being that if you source steel products for these buildings that are state-funded, they must be at or below the threshold set by the Department of General Services. That has presented a lot of challenges. I suspect it will continue to present challenges going forward. One of the right now, it only involves structural material, although there is a proposal to add interior materials. And one of the challenges as a material supplier, the focus in California is on the steel making component of it, not necessarily the fabrication piece of it. So what California is looking for are environmental product declarations for the steel making side, which may not match the same environmental product declarations that LEED is asking for. And it's ironic that these same state-funded projects are also supposed to be LEED certified as well. So again, as the owner of and the producer of environmental product declarations, these things create a lot of challenges for us. In Washington, very similar law with some significant distinctions. It is for public works projects, which not only state-funded projects, so that would include other projects that would be funded by cities and counties and other public works facilities. There has been significant cooperation among the stakeholders there, which includes the design community, several different material suppliers. A variety of us worked awfully hard to try to come up with some legislation that was not only passable, but doable in terms of how it works. And again, the focus there is on structural materials only, all types, including wood. And the environmental product declaration has to represent at least 80% of the greenhouse gas emissions. So we have a different stopping point for the environmental product declaration potentially. Colorado is still in process. It is a post-design comparison only. And there is a slightly more comprehensive material list, so it includes concrete. But again, the challenges there are the EPDs might look a little bit different than what they could look like in Washington and do look like in California and do look like for LEED. We're seeing other action in Minnesota and on the federal level with no real activity at the moment. So again, the challenges here is not just producing an environmental product declaration, which gives us a number. It also has to kind of fit these regulatory guidelines that we're seeing that are sprinkling in around the country. And it does definitely pose a lot of challenges for us as a material supplier. And that is the end of my prepared marks here. So I'll pass this along to Jordan.
Great. Just checking audio. Can folks hear me?
You're good, Jordan.
Great. Okay, thanks for passing it over, Keith. Yeah, thank you for everyone being here. This is fun to present on such a forum. My name is Jordan Palmieri, and I work in the Materials Management Program at the Oregon Department of Environmental Quality. And lately, I've been focusing a lot of my time on reducing the embodied carbon of building materials, which really has given me a strong sense of purpose in my contribution to mitigating climate change. My passion for environmental issues, however, did not start with building materials. It actually started with water. Now, I grew up fishing with my dad, but it really wasn't until college that I understood the deep appreciation for nature that was instilled in all of those different fishing trips. And quite frankly, I just realized that I was happiest on water, which eventually led me to the rivers of Oregon. And after working for a few years on improving water quality in Oregon rivers, I actually found that it was our consumption of materials that was causing most of the problems that I was fighting to fix in rivers. So I transitioned to my current job, which focuses on reducing the impacts of materials. Now, my days on the river with family and friends still revitalize me and drive much of my work. But I've also felt particularly empowered working with building materials because of the craftsmanship, love, and stewardship ethic I've seen from professionals in the field, like many of yourselves on the call today. I've been really impressed by an architect's ability to play the role of chemist, modeler, researcher, and artist. I've also been equally impressed by some of the material manufacturers in the field. Over the last few years, I've been working really closely with concrete producers to help them measure and disclose the impacts of their mixes. I focus on concrete because of the outsized carbon impacts this material has on all of our projects. Now, what I've learned is that most of these producers are material conservationists at their core. They handle and move large quantities of materials daily, which gives them a unique perspective on the need to conserve these materials and reduce environmental impacts. Now, I'm sure many of you are already incorporating low carbon concrete mixes into your projects, but for those of you who aren't, my next slide will cover what I think the architect's role is in getting low carbon mixes on your project. So the first thing architects can do to reduce concrete impacts is to make concrete carbon reductions a project goal. Since the architects provide a central coordination role for much of the project, this is really vital to do as early as possible. And the thing about concrete, and one of the reasons I work on it, is that concrete reductions are really low-hanging fruit. We have the materials, the methods, and the knowledge to make really significant cost-neutral carbon reductions on our projects today. So that's why you hear so many people talking about concrete, because it's low-hanging fruit. The next step is to require environmental product declarations. Many of the other speakers talked about this already, but not getting EPDs for concrete is kind of like buying a car without knowing the miles per gallon rating. Concrete has large carbon impacts, and it's very reasonable to want to understand these impacts on the mixes that are going into your building. The final advice I have for architects trying to lower the impacts of concrete is to get the engineer involved as early as possible and then pass the baton to them, right? It is, after all, their job to write the concrete specs. So empower them to do their part on the project, which will then allow you, as the architect, to do other things. Other things like perhaps supporting more embodied carbon policy in your local communities. Now, when it comes to policy, I'm going to echo some of what the other speakers have said already, and ask you to get involved in measurement and whole building life cycle assessment. I believe measurement and disclosure policies are really the next wave of policies that we're going to see in cities and states across the Pacific Northwest, just like we already see in Vancouver, BC. Now, what I want to emphasize here is that embodied carbon modeling is akin to energy modeling 10, maybe 15 years ago. You know, there's a lot of competing tools. There's not terribly meaningful baselines at the moment, and sometimes you get inaccurate results. Now, we're not going to get any better at this until we start practicing, right? So just accept that it may be messy at first, which is really okay. The other thing I want to advise about LCA is that don't use it as a really precise tool right now. Instead, use them to provide directional guidance for material selection. Even though it gives you 3 significant digits after the decimal place, doesn't mean that it is accurate to 3 significant digits. So use them as directional guidance. The next thing you can do to support embodied carbon policy is to share your success stories. Not only will this empower others to follow suit, but it will also indicate a market readiness that many policymakers seek when considering new policies. I'd also encourage you to share your success stories locally and regionally to influence policy, just like we're doing today at this AIA event. I believe that we need embodied carbon policies at the city and the county level to help drive larger change at the state and the federal level. The next point is about supporting less consumption. Now, there are many scales at which you can act here. Maybe perhaps at the firm level, you could dedicate a percentage of your time or your budget towards the reuse or repair of materials for client projects, or advocate for local zoning policy that supports less consumption by limiting the height, the size, or the FAR of buildings. Finally, I'm asking architects to embrace building code changes to reduce embodied carbon. You know, our data here in Oregon shows that roughly half of the building material related greenhouse gas emissions in Oregon come from the residential sector. Now, the size and the speed of the change needed in the construction sector that Kate laid out in the beginning really does necessitate code interventions, especially in the residential field. So if the commercial field embraces embodied carbon codes, we're much more likely to get residential to do the same thing. So this is where I'm going to stop and turn it back over to Kate. Thank you.
Okay, thank you. And I'm going to ask Jordan to leave his camera on, and I'm going to invite in our other panelists to bring their camera on, because we're going to go into the discussion phase here of our talk. And so I'm going to be asking some questions here, and we might have some slides that come up, or we might just talk to them. So we'll just sort of see how this goes. So first of all, thank you all for those really interesting interrelated comments. I'm going to start with Kjell, and I'd like you to talk a little bit about what the AIA is doing on climate action. How does this fit into work that's happening at a national scale, or even existing commitments and things like that? Can you give us a sense on how that fits in?
Yeah. So the AIA at the last convention last year did a floor vote on making a significant change in how the AIA runs and how what it supports in its resources. And 93% of the people voted for substantive climate action. And so the AIA is right now, and it was going to be, I think it was going to be released on Earth Day, but it was delayed due to coronavirus, writing up an action plan, a climate action plan that would change the way the Institute functions and supports architects until such time as carbon neutral design is standard practice among architects. It's a pretty significant statement and a pretty significant plan. And I've been a little bit involved in it. I think Lisa Richmond, who was on the call earlier, is more involved in it. But it would involve, significant investment in how to do embodied carbon modeling among architects, as well as how to engage in energy modeling as well. I don't know if that answers.
Yeah, I think that does. Maybe I'm going to then ask Jordan to talk about a little bit more about how existing policies, or that are, what some of the, a little bit more detail on some of the existing policies that are happening. We had some questions about where that's happening. Could you fill in a little bit on that?
Yeah, sure. And feel free to bring up the slide if you've got it, Kate. But I think Keith did a really good job of covering some of the Buy Clean policies that are out there. And really in 2017, Buy Clean California, led off with a policy again that requires EPDs. And so this is where we're talking about, optimizing carbon at the material scale. And that's basically, how do we get the most efficiently made material possible? And that's what EPDs are really about. They led off with a policy in 2017. Both Oregon and Washington also had policies in their legislatures in 2017. They did not pass in Oregon or Washington, but Buy Clean California did pass. California only covers flat glass, structural steel, rebar, and mineral wool. So it's a very small subset of total materials. So I would agree with Keith that, we really do need to expand these to all structural materials and many enclosure materials as well. But Buy Clean really laid the groundwork for other states to do similar things. So besides Oregon and Washington, there's efforts in Minnesota. There's efforts in New York State, specifically just around concrete right now, requiring EPDs, setting limits and so forth. And then there's a federal Clean Futures Act that basically replicates the Buy Clean California. A little bit more down at the local level, we see a couple of good policies. One at the city of Portland. This is a government purchasing policy that will require concrete EPDs for all city purchases. And like Buy Clean California, it's a similar trend in that it requires EPDs. Then they're going to set a global warming potential threshold, and then all purchases will need to meet that threshold. Very likely to influence the private market around Portland as well. Really want to applaud Marin County. They really laid the groundwork for incorporating concrete limits into building code. California, they're able to control building code at a local level, whereas many other states, including Oregon, they control the building code covers the entire state. So there's a slightly different challenge in getting building code passed at a state level versus a county level. But nevertheless, Marin County instituted limits for both cement and cement, and they also gave an alternative compliance pathway for global warming potential. I think what I wanted to emphasize here is that some of these local policies really can be taken and replicated elsewhere. So do that. And then the next one, as far as existing policies go, and we all kind of mentioned this, is whole building LCA disclosure. City of Vancouver, BC requires whole building LCA for buildings that will be rezoned. So it's only a small subset of total new construction, but nevertheless, it really started off by really setting that precedent for measurement and disclosure. And that's where, some of the existing policies fall today.
Thanks, Jordan. And could you talk a little bit then about future policy?
Yeah, sure.
Like where in the crystal ball of the world, where should we go? Or where is it going?
Well, let me get out my crystal ball here. You know, when I think about the scale and speed at which we need to address some of these issues, the first thing I think about is zoning code. This is really a huge policy lever that is really not often thought of as an embodied carbon tool. Where you build, the size of your building, the height of your building, whether or not parking is required, these are all huge influences on the final embodied carbon of an actual building. So I see more people playing a role in zoning code. I could envision a future in my crystal ball where perhaps we take a snapshot of the existing embodied carbon within a zoning district, and perhaps make targets that are, you know, below or above where the existing the snapshot is, and permit buildings based on the amount of embodied carbon allowed within that district. So that's zoning code. The next is building code. I really hope that we start using this more, like Marin County's done for concrete. I think, you know, building code can be used to limit the global warming potential of specific materials, or even ban some certain materials. You know, materials that come to mind that are probably first up would be concrete, insulation, and some mechanical, electrical, and plumbing products. But then again, building code could also be used for simpler ideas, like just how do we institute protective overhangs on our buildings so that our materials are protected? Or why are we not just requiring advanced framing on all residential construction at this point? And then finally, building material reuse. You know, the reuse of buildings and materials are really going to play a key part in our future economy. And I know a lot of people think about circular economy here for reuse, but I do want to distinguish between the reuse of buildings and materials versus, you know, recycling. You know, we are not going to recycle our way out of climate change, but we really do need to be thinking more holistically about how we should be reusing buildings and materials, and how to use buildings as material banks for the future. So I guess the last thing I'd say about reuse is that practicing reuse at a building or a material scale also, you know, creates an ethic and a culture that will spill over into other parts of our community and our society. And really, at the end of the day, this is around consumption of materials. And so hopefully we can embrace that ethic of reuse beyond just the building sector.
Thanks, Jordan. That sort of makes me think to Landry, because you mentioned a little bit about the relationship of what, you know, where you have leverage and what type of action you can take as an owner, and where you see the possibility of that, and how that fits in with policy. And so sort of the relationship of how private sector actions can be driven by private sector goals or climate commitments, and how that overlaps with sort of broad sector policies. So could you give some thoughts on that?
Okay, so that was a lot to unpack, Kate. You got to give me small questions. Okay.
Well, okay, so you can go for it. Pick any part of that.
Let's start picking apart commitments first, right? So I joked around a little bit about commitment organizations a little bit earlier. I hope I didn't offend anybody or push anybody off. Bottom line is that you're either driven by code, right? The carrot and the stick, right? I mean, come on. Or you try to present yourself as an early adopter, get out there in front of things, knowing that it's gonna become code eventually, and you're just desensitizing yourself or your customers to whatever that price signal that market change is, right? So with the pandemic in place, you know, we were very close to a lot of states making action on climate action plans and carbon pricing and things like that, which would have moved the needle, you know, perhaps on a lot of what we do in the built environment. But with those things not in place, again, I fall back on being able to control something. It should not be shock to anybody that the price tag of fossil fuels is not even realistic. You know, the things that are happening on the global market. We've got this entire global market which revolves around a completely falsified price and subsidized price of a thing which drives our GDP. And so you've got all these things that feed into that. I can't control that stuff. I really can't. But I can attack EC. I can drive change. And not to pick on Keith and the steel industry, it's not just steel. He's absolutely right. It's the entire built, space. So we made a decision last year, obviously not having a clue about a virus coming our way, but just understanding that we had much more control over EC than we did over operational carbon, and that we knew that code was going to drive operational carbon more than the EC, right? So we said, hey, look, we can get in front of this, we can make commitments, and we can do it. So in our corporate, report last year, we said, hey, look, we're going to do carbon benchmarking on every single new construction project and major renovations that we've got where we touch the buildings, and we're going to target a 10% reduction. We felt that was reasonable. We have a stretch goal of 30%, which is in line with the pilot credit that LEED announced that the USGBC announced at the last agreement. So getting back to kind of the commitment thing, which was one of the three things that I simply said, it's like you just got to do this stuff. It's not hard. It's not going to cost a lot of time or a lot of money, but somebody needs to throw a dart out there and say, well, just like I think it was Jordan that was just saying, hey, it just needs to be directional guidance right now at this point. We don't need to fly to Venus on the amount of kilograms per square foot, right? It just needs to be like, oh, that's a bunch or it's not. And then how do we deal with that or move towards neutrality? And there's tons of ways that you can be neutral right now without attacking the materials. We could be buying, verified offsets. We could be buying green power and going back into that kind of total circular economy until we get solutions that actually affect those materials or affect other things. So there's tons of ways you can do it. It doesn't necessarily have to be, attacking the materials. They're not the enemy here. We're going to build for another 3-4 millenniums, and we're still going to need concrete and steel in order to do it, right? So that was a big kind of ramble. Sorry. Did that answer the question, or give me some guidance?
Yeah, I think your ramble answered my ramble pretty well.
Thanks a lot.
Thank you. So when I look in the chat and the questions, I'm starting to see a lot of some technical questions. So I want to dive into the technical, weedy questions. So I'm going to start with Kjell and then move to Keith, and I'm going to talk about implement and Jordan. You can all pipe in, because we're going to talk about implementing environmental product declarations. So I'm thinking people are asking questions like, is it how do you even ask for them, and what do you do when nobody has the data? So maybe I'm going to just ask Kjell, what does it mean to implement asking for EPDs, and what happens when people don't know what you're talking about?
Yeah, that's a great question. So LEED, well, a lot of our projects are LEED, and if you get 20 EPDs on a project, you get a point. That's really easy to do. And that actually spurs our teams and our owners to say, hey, why not do that? So that just means we do a bunch of research, figure out where we can get EPDs on our products, and that's industry-wide or mill-specific. And then we request that in the Division 1 LEED sustainability section. And then we also put a reference to that in each of the other sections. Now, we often go for the LCI credit under LEED as well, and that means for all the structural materials and enclosure materials, we're also going to ask for EPDs. So, if you start with kind of with that approach, I think a lot of the people out there are probably familiar with getting LEED specifications that are asking for EPDs. Now, you can ask for it on any product, and that doesn't mean it exists. If you go to EC3, and there's a couple other, go to the EC3 website, you can search for EPDs that are local to your area or anywhere, and see if they exist. So as soon as you know they exist, you can ask for them. And you can, often what we do is we specify 3 products, maybe 2 of them have EPDs, 1 of them doesn't. But we've at least given them a fighting chance and said that you must submit the EPD if it exists. That also tells the manufacturers that, hey, this is something we're asking for. We've also allied with others in our industry and written letters to manufacturers that we send to them saying, hey, we want EPDs. And because, I don't know, ask the other panelists, how long does it take to get an EPD? Yeah, it's too late if we spec it and hope that, a month later we're going to get a product that has it. But how long does it take to get one? That's kind of that's why we would set out these warning letters as we do project after project, saying, hey, you know, we're going to ask for this, we're going to ask for this, and then you can eventually, you know, you'll be a preferred supplier. But a lot of the, in the specifications that goes in Division 1, a lot of the overall project requirements in the sustainability section, and then we reference it in every technical section that we're asking for an EPD. That's how it gets done.
So maybe, Keith, could you kind of come in from a manufacturer's perspective? How are you hearing from the market? You know, where do you hear that people want them? How long does it actually take to get one? I mean, I know that every industry is different, but from your perspective, what are you seeing?
Sure. I think to answer Kjell's first comment there about how long it takes, you know, typically you can get an environmental product declaration in 3 to 6 months, depending upon how complex the product is, and depending upon if you have any of that data collected in order to do that. Generally speaking, the data collection process is the longest component of it. And certainly products that are sort of within the same family can use a very similar LCA model, which simplifies things rather dramatically. So there are a lot of variables in that, but generally speaking, if you figured 6 months to get an EPD, that's probably relatively close. Can be certainly done sooner than that, and it will certainly take longer than that. From a manufacturer's perspective, one of the things that I mentioned in the opening comments are the challenges that we're seeing currently, for example, with some of these buy clean laws. Literally, there are opportunities for having at least 2 or 3 different EPDs that represent ultimately the same product that you can identify on the job site, depending on whether that product is sold in Washington or California or Colorado or a lead project in Illinois. So from a manufacturer's perspective, you know, some commonality there becomes important. Yeah, you know, the environmental product declarations are great, and I also know that this particular presentation is a focus on embodied carbon, which is clearly important. But one of the selling features, if you will, of an environmental product declaration is the fact that it's a holistic approach. It's a life cycle analysis. It's not a single attribute. It's not just recycled content. It's not just embodied carbon. So we lose a little bit in the value, if you will, and trying to oversimplify this on some level. So it's important that, you know, you really try to get your head wrapped around what is in an environmental product declaration, what it can teach you, what it can tell you, not only from a manufacturer's perspective, but obviously as an end product user. So is there a follow-up to that maybe, or?
Yeah, there is a follow-up. There's a follow-up. There's sort of 2 things. So can you learn something as a manufacturer by creating an EPD, and how can you actually change your process? Or is it just sort of just like reporting what is? Like what can you take away from conducting life cycle assessments?
Yeah, you know, and again, it depends on the product. For a product, I'll take an example of sheet steel. Sheet steel is not a product that shows up on a job site. So to do an environmental product declaration for sheet steel is not usually a valuable exercise. However, the life cycle analysis that the EPD would be built from is a valuable exercise. So we don't always have to take anything to an environmental product declaration in order to get valuable information out of it. But that entire exercise does show you some hot spots in the manufacturing process, some places where there may be some opportunity, certainly allows some comparison across different locations in some cases. So there are lots of things you can learn by going through that exercise. If nothing else, it gives you some visibility on where the emissions and the energy is actually spent. So, you know, while capital intensive industries like the steel business and the cement/concrete industry can't necessarily just pick up and move just because, you know, it's 5 miles closer to the job site, it just doesn't make sense to do something like that. However, there are certainly some things you can do within the box you're given, if you will, that can allow you to improve and continue to make improvements.
You're on mute.
You're muted.
Can I
Kate.
turn to, thank you. Can I turn to Cassie and Zoe, who've been moderating the questions, and see if there are a theme or a couple of questions that would be good to be bringing out to here?
Thanks, Kate. I'm just taking a look. I know that there's some
Okay.
technical questions. Did you address?
Love to answer that question about parking garages. Somebody had a question about building for deconstruction and parking garages, for example.
Thank you.
You know, parking garages are a big, huge carbon sink, to be honest. They're made out of literally concrete and steel, and the only thing they do is park antiques, in my humble opinion. 50 years from now, cars aren't going to be the same thing. We're not going to transit the same way. Got to believe in that. Got to understand that. And so building for deconstruction of parking garages is definitely something that is a push and pull for an owner. Bottom line is I can't build a building if I haven't parked it. That's code. There are very few codes other than Seattle that are forgiving enough to say, okay, you can underpark your cars, right? So more and more, we're trying to come up with ideas that we can build for either future use or for deconstruction. So instead of building a parking garage that may only have like a 8 or 9 foot floor to floor height, we're going to build double-sized or full 19 foot floor to floor heights and things like that, and then use stackers inside of those garages so that one day we can potentially use those spaces. Another option that we've done is that we've done part concrete and steel and then part other products, think mass timber, in order to build for deconstruction in the future as well. And so being smart about your design and how you build for in-state or a future use change is definitely part of what we're thinking about in a low carbon future.
And that makes me think to Jordan and the deconstruction ordinance, because there's a question about, there's been lots of talk about reuse of materials. How do we actually get the reuse of materials? How do we get a supply side demand for those reused materials? And I understand this policy is creating those. Can you talk about that a little bit?
Sure, I can chat about that. So I think it was quite a few years ago, 2016 or 17 at this point, the city of Portland passed a residential construction policy, which requires that residential homes being removed from the site be deconstructed by hand rather than mechanically demolished. At first they started with only homes that were over 100 years old, that were built in 1917 or earlier, and they recently expanded that policy to include homes that were built in 1940 or earlier. They did that both to capitalize on the quality of materials and that vintage of homes, and they also did it to sort of phase it into the market so they weren't flooded with too much material or too little labor to actually fulfill the job. But long story short is that the policy's been very successful in deconstructing homes, which has added benefits of reducing dust and lead and asbestos that could be being spread during it. But there still are challenges locally for the value of deconstructing a building and salvaging the materials is only fully realized once somebody actually uses that salvaged material and displaces the production of new materials. So as a part of that, to help encourage people to reuse materials, there was a building code change that happened in Oregon that now by default allows you to use salvaged lumber, both in residential and structural code. And I'm pretty sure that just passed in Washington state on the residential side. If I'm not mistaken, someone else on the call might know better than I would. So that's, getting the permission to do it is one of the first steps, but then actually doing it is another good step. So, I've heard a lot of ideas about how do we sort of prepackage salvaged lumber like a normal lumber package would be. How do we use salvaged lumber in different sort of more modular ways? Like how do we use them to, construct, cubicles and office furniture that can be reused and moved over and over again. So I would say that it's not solved and that there still needs to be more actual demand for the use of salvaged materials. Maybe we'll see that through different projects. But that maybe I'd turn back to, the architects and the contractors to see how we can increase that demand for that material.
Yeah, I'll just say in response to that, you know, architects often design buildings that are going to be built a year or two after the products are going to be procured a year or two after. So there needs to be either a constant stream of that reused material if we're going to be able to guarantee they can be constructed on time, and so there needs to be warehousing or something to, you know, maintain that material so we can get, you know, 10,000 board feet of it, or, you know, 800 square feet of that, or 1,000 square feet of this. And we know we can get it 2 years from now, or else we're designing kind of in the abstract. And then there needs to be some cost certainty around that as well. That would certainly, you know, help. But design for deconstruction is a huge topic that we don't have time to get into, but it's, you know, it's something we're diving into right now and trying to figure out what our biggest efforts can be in that arena. Certainly, one of the things our interiors people say is, at least from our clients' perspective, it uglies out before it wears out, meaning often building products don't last the lifetime that it would exist if until it wears out. Often it's replaced before it wears out, which is, you know, another waste of embodied carbon, but an opportunity for reuse.
Good. Let's see. Cassie, are there any other ones that you want to really highlight, or should I just keep going with some questions?
Keep going with some questions if you have them, Kate.
Okay.
Well,
let's see.
Wrap up.
I could help. I could have some help. I'm getting distracted by all those questions.
Well,
let's see.
Code, and also definitely some materials and kind of ingredient, like thinking about the future of transparency, how that's going to change. Washington Salvage Wood Code.
So let's see. I think maybe that kind of goes to one of the things that Keith brought up, is how do we connect multi-attribute issues with materials? So how do we connect embodied carbon to health, to manufacturing health, to reusability and end of life? So I sort of throw that out to the panel. Maybe I'll start with Kjell. How when you start prioritizing embodied carbon, I bet in your office there are some people that are all in material health, that's their dominant criteria. Do you have interesting discussions and debate in practice about, are there trade-offs and how that works?
We do. So we have a research group that's focused on materials and health, and we have a research group focused on embodied carbon and mass timber. And there's overlapping members between the two of them, so we have some good conversations on it. There's no way to boil this down. It's complicated. It's very, very, very product specific, and, you know, location specific and all that. I think architects are just really good at doing lots and lots of things already. And any time that the industry can simplify things for architects is really, really helpful. You know, we have the ability to do some amount of research, but ultimately we are we are good at programming buildings, at specifying things, at doing many, many things that we're already doing. And so we're not, you know, maybe 3, 5, 7% of architects are going to know a reasonable amount about materials and health. And maybe that same percentage will know a reasonable amount about embodied carbon. And so how can we make it so we lead those people so they can get informed, so they can lead their firms in being able to take action on this? One way that we do that is we have our materials and health group, which also does some embodied carbon things, has a material vetting process that we go through a certain number of products on, and then we can look at that from many angles and then find if there is an environmentally preferable product from all the angles that we are aware of. And then we can put it out into our base specs. But it's really, really complicated.
Okay, so that's an interesting thing. It's complicated, but we have to do it. Jordan, you look like you're ready to say something. I was wanting to prompt you on a little bit of end of life impacts, because you're looking at material management.
Okay, I'll take a quick shot. Okay, I'll take a quick shot at the material and health one, and I think it's difficult to balance them all, and I would say that this is where we do need to start relying, and many people are already relying on third-party certifications for all of this, right? I mean, that's what EPDs are for embodied carbon, the third-party certifications of the embodied carbon of your product. And then when we look towards material health and we look towards Cradle to Cradle and Declare and a number of other ones that actually are following that trend, we are measuring and we are disclosing. I think the beauty of measurement and disclosure from manufacturers' standpoint, as I interpret it, is that those that are doing it really are making changes. They are making changes, they are learning things about their product, and they are putting it out there to the world to see. And those, we should be rewarding those companies. We should be responding by using their products. And I know this has been kind of going back and forth in the industry as saying manufacturers said, we did this, we measured, we disclosed, but we're not seeing people specify the products that are measured and disclosed. And so I do think there needs to be a connection there, because it is a lot of effort. And I know that, you know, we run incentive programs around measurement and disclosure. And the reason why we did it is because after talking to a number of manufacturers that do this sort of thing, we found out that these do result in genuine improvements in the product, whether it be on a carbon scale or on a material health scale. So relying on these third-party certifications and not having to be the all-knowing architect that is the researcher, the chemist, and the designer is I think a way that I would point people.
And Jordan, I'll add to that two more things that I thought of while you were talking. One is, you know, for ceiling tiles, we found one that is red list free and has a lower embodied carbon, so we're going to use it. You know, it checks a couple of the boxes, a couple of the big boxes. Another one is insulation. It's probably the biggest thing architects have control over, that has embodied carbon as well as operational energy savings potential. So, you know, we focus a lot of our time on looking at the insulation, and as new glowing agents come out for insulations, you know, the market is always changing. And then, you know, Washington just passed a law that now will change some of that stuff as well. So it's something we focus on, and something, if you're an architect, that's a good place to start.
Keith, do you want to add something there?
Yeah, I mean, I guess on the end of life issues, I mean, we're kind of a little bit of an expert in end of life issues. So we recycle approximately 23 million tons of steel a year. Put that in perspective, that's one car every 2 seconds around the clock the entire year. One thing about steel is a very unique product in a sense that the scrap steel is actually worth more than iron ore for a couple of reasons. So in this particular case, the circular economy is pretty easy, and in this case, recycling does matter. Recycled steel content has all the embedded alloying elements and other things that you would have to add if you started straight from iron ore, so it eliminates that. Again, the process, the electric arc steel making process, uses significantly less energy and has significantly lower emissions than starting directly from iron ore. But there are also limitations to that. You can't always only use scrap to produce all your products. So there is a balance there someplace. So yeah, on the end of life issues, the end of life concerns and how a product, the disposition of the product at the end of its life is important. So I mean, one thing, for example, a concrete frame building has a lot of steel in it, and a steel frame building has a lot of concrete in it. So at some point, it's not about the material so much anymore. It's about how you build it. A steel frame building routinely we can recycle 98–99% of the steel in that building routinely, because nature made it magnetic, so it's pretty easy to get it out of the supply stream. Whereas steel embedded in a concrete frame building becomes far more difficult to get out of that concrete to be able to recycle that steel. So Typically, a concrete frame building is recycled at the rate of about 70–75%. The point there is if you have the same ton of steel in both buildings, one building makes a difference at the end of its life where the other building does not. To a steel maker, scrap is scrap. We can upcycle scrap or we can downcycle scrap. It really doesn't matter. Again, how the building is designed, regardless of the structure itself, becomes an important consideration downstream at the end of its life. And I think that same thought process is the same regardless for steel, regardless if it's recycled or if it's reused.
Well, thank you. I think we're coming to the end of our time. I want to thank everybody for participating. I'm going to say my three main takeaways. The impacts of material manufacturing are significant. We can do things now to drive towards decarbonization of this industrial sector. You don't have to understand everything to take action. So find where you can take action and take action. So if it's just insulation, just become the embodied carbon insulation expert. You can go a long way in helping us move forward. So thank you all, and thank you for the AIA and all of the panelists for joining today.
Thank you, everyone. Kate, Jordan, Landry, Kjell, Keith, I really appreciate your time and expertise. Attendees, thank you so much for joining us. Up next at 1:30 p.m. Pacific time is Electrification of Buildings, Designed for Decarbonization. Another hour-and-a-half session that's a couple of case study presentations and also a panel discussion. You can visit the website for a full list of program schedule, speaker bios, other information. A reminder that all of these webinars are being recorded, so they're only offered for continuing education credits by AIA Seattle Live, but you will have access to the recorded content. AIA Seattle is also going to put together a couple of roundtable discussions. Next week, we recognize that 300 or 400 people is a lot for engagement, so we want to continue the conversation, and all the questions you posed today will be really useful for that. Final thank you to our sponsors. So hope to see you at 1:30 and reach out to Zoe and I if you have any questions. Thank you again, panelists and Kate for moderating.